I'm not live. You're live. This whole place is live. Live. We did it. Hello, everybody. How's it going? I am still figuring this whole thing out. Check the frame rate is 160. I can't do the frame rate now. So we'll have to go with the frame rate that we had before. Oh, maybe I could edit it. It's not going to be fun. It's not going to be good television. Oh, and yeah, I can't do it right now. Sorry, Chad. I will get it. I'll get it next. I'll get it for next time. Promise. Yeah, the shutter speed. Yeah, so the shutter speed is... Yeah, I don't have an easy way to... Let's see. So I could change the... Yeah, I don't want to mess with it and bork the actual recording. So yeah, the shutter speed. So I don't have an easy way to change the shutter speed this time, so I'll do it for next time. Unless you want me to stop the recording. Just gripping television. Yeah, okay, all right. Hey everyone, how's it going? Welcome to Monday Open Space Live. Your questions, my answers, blah, blah, blah. You know how this goes. So, interviews. We're back to interviews. Remember when we used to do interviews? We've got Dr. Brian Keating coming up on Thursday at noon. So, I've interviewed Brian before, but we will have another chat. And then I've got Lee McIntyre. And I don't remember why. Hold on. Right, the philosopher Lee McIntyre. Right. So we're going to be talking, he wrote a new book called How to Talk to a Science Denier. And so we're going to be talking about science denialism on Monday morning. And then on Tuesday, I've got Les Johnson, who works at NASA and works on a lot of really interesting advanced propulsion systems. So we're going to be talking about advanced propulsion systems with NASA and space exploration. And he's also written science fiction books and stuff. So he's pretty cool. So yeah, I got 3 interviews coming up in the next less than a week. Well, a week. The next week, I've got 3 interviews so far. I've got someone who's going to probably come and talk about asteroid impacts. And yeah, so I've got a ton of interviews. So buckle up as usual. You forgot what it's like to be during the regular production schedule of all of this stuff. All right. Okay, so let's get started. Now, I have no prepared questions this week because we still haven't published last week's question show. So we're just going to go right into your live questions. Starting the recording. Starting the audio recording. All right. Let's see if this... Oh, recording reminder. Yes, I am recording. Okay, here we go. Hi, everyone. I'm Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy journalist for over 20 years. This is our question show. Your questions, my answers. Now, wherever you are across my channel, if a question pops in your brain, just write it down, and I gather them up and I answer them here. But we also record this show live every Monday at 5 p.m. Pacific time. So if you want to come and join the live show, ask your questions, follow-up questions, stuff I've never seen, definitely come and join us on Monday at 5 p.m. All right, let's get into the questions. Okay. Mr. Dobalina. Hi, I have a question. What is the difference between the observable universe and the Hubble sphere? Great question. Now, I did a whole episode with Dr. Paul Sutter where we went through this entire process and discussed what is the difference between the Hubble's, the different kinds of cosmic horizons, from the observable universe to the Hubble sphere to other various cosmic horizons. So I'll put a link to that in the show notes. But the question that you asked is, what is the difference between the observable universe and the Hubble sphere? So the observable universe, of course, is the region of the universe that we can see that is within the amount of time that has taken light to travel from the Big Bang to here. And that is about 13.8 billion years of time. But the universe has been expanding, and the galaxies have been moving, and the Milky Way has been moving. And when you add up all of that, you get about 94 billion light years across for the size of the observable universe. And so objects which are half 46.5, is that right? Anyway, 92 billion light years. Anyway, so half of that. So about 46 billion light years in one direction. The galaxies that are there, or I guess the cosmic microwave background that is there, is almost the beginning of the universe. And the light has been traveling to us for 13.8 billion years. And the universe has been expanding and the galaxies have been moving. And so that's how you get this distance. And it's sort of, when you think about it, right? Like shortly after the Big Bang, sort of during the era of inflation, the entire universe, the entire observable universe, was about the size of a golf ball. But it wasn't the whole universe. There was more universe around it. So imagine like an infinite universe and just this tiny golf ball sized chunk in the middle of this infinite universe. And that one little piece has expanded up to the observable universe that we see today. But you could move over one golf ball size and get a completely different observable universe that doesn't overlap with our observable universe at all. It kind of blows the mind. So the Hubble sphere, the Hubble volume, this is the region of space where the galaxies are essentially reachable by the speed of light. And so beyond that region, galaxies are starting to fall over the cosmic horizon, that they are, due to the expansion of the universe, they are, from our perspective, moving faster than the speed of light to us. And it's actually a much smaller volume than the observable universe. If you sort of like divided the two, about 94% of the observable universe is unreachable, is over that cosmic horizon. And so these galaxies, they're there, we can see them, but we could never get to them from, even if we could go the speed of light. And they will fade away, redshift into the red as their wavelengths of the photons stretch out, and they will effectively disappear from our view. And over time, more and more of the universe will fall over that cosmic horizon and disappear. Moochie the Cat. What are the ramifications of satellite access for consumer-grade devices? So we saw this week that Apple's iPhone 14 is going to be allowing you to send an SOS call on a satellite network on Globalstar, and Starlink and T-Mobile have announced that you're going to be able to make satellite phone. Again, in the beginning, you'll be able to make text messages, but eventually you'll be able to make phone calls on their service. So, like, what are the ramifications? Well, this is the satellite networks today. You can imagine over time, as the satellite networks get bigger and more complete, then they'll be able to offer more and more bandwidth. The thing that was really surprising to me with the Starlink, and actually there was a company called Link that we've written a couple of stories about on Universe Today. They actually built a CubeSat that has been able to connect to cell phones as it's flying overhead. And when you think about it, like space is just, there's no obstacles between you and space. It's just the strength of the signal. And so as long as your phone can reach the satellite and vice versa, then you can theoretically connect back and forth. And obviously we're in the very initial stages of this, but like, do you remember when you first got Wi-Fi, or, you know, for the people who were alive when Wi-Fi showed up, as opposed to the kids where Wi-Fi has just always been around? And it sucked, and it was slow, and it barely worked, and yet it was still kind of magic that you could be not on a wire and be able to use a device like your computer, your laptop computer. And so obviously we're just going to be marching headlong into this world where every device that you own will either connect to a Wi-Fi point or be able to connect to the satellite network. And no matter where you're going to be on Earth, you'll be able to connect. I have this like story. I was driving in the US with my kids, and we were like on a big long road trip, and it was about like 10 years ago or so. And we were trying to get Wi-Fi to book a hotel. And so we had to park in a McDonald's parking lot to try and get their Wi-Fi. And I was like laughing with the kids saying like, kids, just remember this day, because this will be the look back hilariously that your dad had to figure out a way to be able to connect to the internet so he could book a hotel room, and that problem will go away. And now we are. Your cell phone through the cell phone towers is very fast. You can watch videos, etc. The next step, of course, is that you'll be able to do this anywhere on Earth. So, I mean, what are the ramifications? You can be hiking in the middle of the forest. You can be out in the middle of the ocean. You could be sailing around the world. You could be in the middle of a desert, and you'll still have high-speed internet. You'll still be able to connect. People won't get lost as easily, I guess. It's hard to say. I mean, this is one of those technologies that is going to come quickly. We're not going to really appreciate all of the ramifications of it until it's really deeply embedded into our society and our culture. So, it's going to be fascinating to watch and see what happens. Now, obviously, the downside is that there's going to be 42,000 satellites from Starlink. There's going to be thousands from Kuiper and the other satellite networks. So far, I mean, they're not hampering the sky for your regular eyes. They're definitely hampering the sky for telescopes. There's a few upcoming satellite networks which could be devastating for the view of the night sky, like really bright satellites. So I really hope that they don't happen. But so the other ramification is that if they get big enough and bright enough, then they could fill the sky with satellites. But if the path continues today, like if we get Starlink-sized satellites communicating with the Earth, it should probably be fine. But in order to make this cell phone network work, they got to use the next generation of Starlinks, and they're bigger, probably brighter. So I think the ramifications are we get to communicate with the internet anywhere on Earth, and the night sky is taken away from us just a little bit more. Alexandru Vataman. How does Jupiter's magnetosphere affect the expected life on Europa's oceans? Why are scientists still expecting life with such conditions? Thanks. Yeah, the magnetic field around Jupiter is much stronger than the one that we have on Earth. And the same thing that happens, this idea of like the Van Allen belts, this trapped radiation belt is there at Jupiter, but it is much more severe. And it's so severe that when NASA plans the trajectory for its spacecraft, they try to make them spend the absolute minimum amount of time passing through these really intense radiation belts. Europa happens to be just bathed in this radiation. If you were out on the surface of Europa, you would receive a lethal dose of radiation within 24 hours. Like it's it's deadly. Something like 1,800 times as much radiation as what you would experience just out in space somewhere else. So it's bad. But water is an incredibly good protector against radiation. It's just as long as you got a lot of protons, you've got good protection from radiation. And about a meter of water, or ice in this case, is enough to protect you completely from the effects of Jupiter's radiation. And not to mention Jupiter's radiation, solar storms, cosmic rays, you are completely protected. And so when we think about life on Europa that could be hundreds of kilometers underneath the ice, no radiation is getting through that. Now, if we do send a mission to Europa, the risk is going to be, can we have the spacecraft land on the surface of Europa and even survive? But one of the benefits is that if we did bring any nasty Earth life with us, it's going to be bathed in radiation and it could sterilize the spacecraft. But one of the issues is this layer between the surface of Europa and under the ice. And if we send a lander with a drill that's going to attempt to search for life on Europa, you're exactly right. If that life, or if we can only dig down within that first meter of the ice, we're not going to be able to find anything because everything is going to be irradiated. So any mission that's going to be searching for life on Europa has got to be able to dig down more than a couple of meters. Ideally, dozens of kilometers to reach the subsurface ocean, but still, if you can at least go a couple of meters down. And this idea of water is one of the best ideas for just protecting human beings from radiation in space. Like if you want to go on a mission to some place in the outer solar system and you can take a couple of years, enclose your spacecraft in water ice. Let it freeze. It's both your source of water, it's your source of air if you need to. You can break it up. It's your source of propellant, and it is your radiation shielding. Water's great. Thanks for the donation, Sunny Vegas. Pat Lev. Lunar polls. Information? Question. Good question, Pat. Right. So the poles of the moon, they are, you didn't really ask a very specific question, so I'm just going to generally go on about the poles of the moon, and hopefully you will be able to pluck out the answers that you were hoping for. But the moon's poles are the places where scientists believe, or kind of know at this point, they are in permanent shadow and that there are deposits of water ice that are located at the poles of the moon. And so the moon is within the frost line of the solar system. And so the intense radiation of the sun will vaporize any water ice that is just sitting out. Like if you had a ice cube sitting out on the moon, it would sublimate away into space. But around the poles, you've got, because the moon orbits around the Earth, and it has these craters at the north and south pole, as well as mountains. And they cast these long shadows that keep regions inside those craters permanently shadowed. And NASA and other groups have sent spacecraft to the moon, and they've been able to detect water ice. The Indian Chandrayaan telescope, or the Indian Chandrayaan mission, was the first spacecraft to actually detect the presence of this water ice on the moon. And so this is the target for upcoming lunar exploration. Both China and NASA have targeted the south pole of the moon as the best place to go to send humans. That if you could actually sit down on the moon, you could bring some kind of gear and technology to be able to extract water ice out of that permanently shadowed craters. You could replenish your fuel supplies, replenish your water, your oxygen. Water is like really important when you get out into space. And so that is why the moon is so exciting. And so within the next couple of years, we should see the first humans set foot on the moon. In 50 years, we should see them search around to see if they can find these water ice deposits. And over time, hopefully, we will see methods and techniques and technologies for extracting this water and create a sustainable lunar base. So I hope that answered your question, or other questions that you might have had, or questions you didn't even know you had. good question. Amir Kal. Hey, Fraser, you as a person who follows amateur astronomy and uses Starlink as your daily internet connection, what do you tell people who oppose Starlink and its drawbacks? Yeah, I think that there is a overly simplistic argument about Starlink. So, on the one hand, half the people on Earth have no access to the internet. And by not having access to the internet, they are being left behind in this globalization. They don't have access to the bank. They don't have access to the library. They don't have access to medical information, to be able to talk to their doctor, to be able to connect with their friends, just educate themselves in the technology that is kind of required and really gives you an edge. And if you have the internet, then you can research anything, connect to anybody. And if you don't have the internet, then you're permanently kind of left behind. And the rich get richer and the poor get poorer. And the internet is the method for equalizing wealth on Earth. If you have ambition, you can connect to the internet, you can do incredible things. And if you just can't, you're left out. So I think that access to the internet is key for just society and for people around the world. And so that is the promise that these internet companies have made, is that we're going to connect the rest of the world to the internet, and this is the societal good. So if that was true, then that would be fantastic. But of course, like, these are big companies, and, do we trust them? And are they actually going to do it? Or are they just going to make as much money as possible and extract resources the way they always do? So that is the sort of cynical view about what they're doing. Now, the downsides are, I think, also overhyped. So with the Starlinks, for example, the brightness of the Starlinks, they are so dim that you can't see them. Now, you can see them when they're launching in these trails as they are shifting up to their higher altitude, but you can't see them once they've reached their altitude. You can only see them with a telescope. And they're only visible when they're close to the horizon during dawn and sunset. So in the middle of the night, the darkest times, the times when it's best to look at the sky, you can't see the Starlinks or any of the other satellites that are up there. They're just a nuisance in the sort of beginning of the evening and just before sunrise. But there are really important science work that's being done that needs that time. And so a good example of that is people who are searching for dangerous asteroids. The most scary, terrifying asteroids out there are the ones that we don't see, the ones that pop out of nowhere because they're coming at us from the sun. And that means that you need to be able to view them early in the morning or just after the sun goes down near the horizon. And you've got to do these giant surveys where you're looking at frame after frame after frame of the sky. And it's really easy to get a Starlink passing through, obscuring your view to the asteroid. And it's probably happened that people have searched the sky and they didn't see an asteroid there, but actually there was one, but it was blocked by the trail of the Starlink. So right now there are a couple of thousand. Imagine what that's going to be like when there's 42,000 of them, just Starlinks, not to mention the other satellite networks. And then the other issue is the astronomers, the ones that are doing, say, work with the Vera Rubin or these other giant surveys that are doing observations on galaxies and so on. They are going to have multiple paths going through their views, and it's going to be degrading the quality of the science that they can do. And so I think, like, if you came to me and said, every person on Earth will be able to connect to the internet at a reasonable price and be able to join in this global interaction, and the price that you would have to pay is severely degraded ground astronomy, it's a price I would pay. Because, I mean, astronomy is great, but helping people in Africa connect to science databases so that they can figure out ways to clean their water is important. So I think where everything went wrong is that all of these satellite companies got a chance to launch without fulfilling on that promise without making a deal that they can't back out of, a contract that they can't avoid. Like, imagine if a new satellite company came along and they said, we're going to let the whole world connect. And the government said, okay, fine, put up several $billions as an escrow. And if you don't connect people to the internet at this price that you promised, then you forfeit that money and your company goes into bankruptcy because you had one job and you failed in that one job. And instead of connecting to the world to internet, you made yourselves rich. And so the price you have to pay is you lose it. So I think that it all came so quickly that we didn't get a chance to put brakes, to have discussions, coordinate activity, and really put the hooks into these satellite providers to fulfill on that promise of giving the world connectivity. So that's my fairly nuanced view of this entire situation. And the problem is now the horse is out of the barn. The satellite operators are launching their satellites, they're connecting, they're providing high-speed internet. I don't think underserved regions of the planet are getting their internet yet, and astronomers are losing their skies. So I hope someone is able to figure out a proper balance. More conversation should be had. More agreements should have been made. This is a shared good. We see this problem happen again and again and again, right? It's the air, it's the waters, it's the oceans, it's the common, well, what's the term? Tragedy of the commons again. And now it's going to be space. So the other issue that a lot of people are worried about is space junk. And actually, that's not a big problem. The satellites fly so low that they have to be constantly raising their altitude. And if they don't, then they will crash into the atmosphere and burn up within a couple of years. It's actually a great region of the sky to put satellites because it's self-cleaning. It's the ones at much higher altitudes, ones that are thousands of kilometers high, the ones that will stay for hundreds, thousands, tens of thousands of years. And if they smash into each other, there's really no way to clean it up. So I would rather have satellites go into low Earth orbit, really close to the Earth, than the ones that are higher. So, and then the other thing is, like, if you're not going to use a satellite, what are your options, right, to reach the rest of the world? Are you going to use cell phone towers? Well, cell phone towers kill birds. They are an eyesore. They take up an enormous amount of metal and waste products. They don't last very long. They have to be replaced, etc. Are you going to bury cables in the ground? You got to dig up through sensitive environments. You got to dig up marine environments to lay cables through the oceans. Like, launching satellites seems to be the lowest impact way of connecting the world to the internet. And there are some issues with it, and they should have been negotiated. So that is my highly nuanced view of satellite internet companies. And of course, I am using Starlink right now for like one more month, and then they're gone. But I depend on it. And I wouldn't be able to do this job if it wasn't for Starlink. So here we are. Don't cut me off, Elon. Oh, that's a great question, Tom. I love it. Old gamer noob. Which is more dangerous to Earth? A comet because of its high speed but lower melting point, or asteroids being slower but having a higher melting point? Comets. Comets are way more dangerous than asteroids for a couple of reasons. So the first one is that when you get a comet, okay. So the first reason is trajectory. So when you have an asteroid, you have a lot of warning generally because the asteroid is just in orbit. It's been orbiting around us for thousands of years, tens of thousands of years. And as astronomers map out the region in the sky, they are able to pin down every single dangerous asteroid. And we're at the point now, actually, where every really dangerous asteroid has been identified. We all the ones that'll take out a continent. So now we're down to the city killers that are still unknown and out there. But over time, they will be found. They'll be mapped out, and we will know the location of every single dangerous asteroid that's out there. Comets come out of nowhere. And you have no, like for the long period comets, it's their first trip into the inner solar system, and you have no way of predicting. And so you just get a few months notice before the comet arrives and ruins your day. The speed is an issue. So the asteroids are moving slower, the comets are moving much faster. And at the end of the day, it's about the amount of damage, the energy released is a function of both the mass and the velocity. And when the velocity is higher and the mass is the same, then the amount of energy that's released is much greater. So comets are a little more terrifying than asteroids. Getting a little dark, so I'll change the brightness. Okay. Ooh. Disasterina. How do you see climate change affecting the space industry over the next 10 years? So there's a couple of issues with the space industry that we're already dealing with. The first one is that obviously a rocket that is flying with methane or jet fuel, right, is in putting out carbon dioxide and other greenhouse gases. Now, the amount isn't a lot, but if you imagine this world where Starship is flying multiple times a day, you've got multiple rockets around the world, and a rocket is just a giant tube of fuel, it's big. And it'll have a non-zero impact. Now, SpaceX has said they want to move to this world where they're generating all of their methane on site using solar power, and they're pulling it out of the atmosphere. Sounds good. Sounds far-fetched. It's tricky to do that amount of methane production out of the atmosphere at that kind of scale where you're filling up a giant rocket multiple times a day. So you've got just the carbon emissions. But the other issue is that rockets put out emissions into a region of the atmosphere that nothing else is deposited. So they're actually putting it up in I think it's the troposphere. As a rocket passes up through the troposphere, it's putting out particulate and putting out material into that region. And that has an impact on the Earth's climate. There was a study that I read a couple of months back, and I apologize, I forget whether it was, but it was definitely contributing to climate change, but I forget which way it was going, whether it was locking in more atmosphere, locking in more heat, or whether it was shading the Earth. I think it was locking in more heat. I'll try to dig up that paper and link it in the comments. And then you've got, of course, all of the production of the rocket and all of the material involved and all of that. And then the thing you wouldn't really think about is sea level rise. So you've got Cape Canaveral, you've got Boca Chica, you've got the site in South America for the European Space Agency, you've got where the Chinese launch from. A lot of these places are at the coast on very low areas. Big chunks of Florida are going to be inundated over the coming decades as the sea levels rise. Boca Chica is going to have its problems too. And so imagine having to completely move Cape Canaveral to another location because now it's just underwater too often that you can't launch rockets there. So I think that obviously, like any industry, the rocket industry is going to have both, it's a contributor to climate change and it's going to be impacted by climate change. And there's kind of no way around it. There you go. Yeah, Vista Tutti is saying stratospheric methane. I think that's what it was. Stratospheric methane is being ejected by the rocket as it's flying. Pray for our country. Lunar Gateway or moon base? My vote is moon base. Well, it's not an either or. Like, the whole point of the Lunar Gateway is to make a moon base easier. It's kind of like saying a base in Antarctica or a port at the bottom of South Africa, right? Like, being able to fly down to South Africa, hop in a boat, and then go to Antarctica is vastly more convenient than attempting to just fly to Antarctica or take your boat from, I don't know, Europe all the way down to Antarctica. And so the Lunar Gateway, if it works the way it's envisioned, is that you've got this stepping stone point, this satellite, this space station that is orbiting close to the moon. It's not orbiting around the moon, but it comes close to the moon on a regular basis. And then you've got the lander that's detaching from the Lunar Gateway, flying down to the moon, landing. The astronauts are hopping out, collecting rocks, jumping around on the moon, looking for that water ice that we talked about before, and then they get back in the lunar lander and they fly back up to the base. And the whole thing is reusable. And then you've got a ferry that carries you from the Earth to the Lunar Gateway. And maybe that's also Starship, something that's fully reusable. And so when you think about the Apollo era, like the whole stack of the Saturn V and the capsules, that whole thing was thrown away. And the only part that made it back to Earth was just the little capsule on the top. And with the new system, in theory, you've got a reusable first stage rocket. If you launch with, say, a Falcon Heavy, like, I'm not like, forget about SLS. I mean, obviously that's how it's going to work today, but that's not the vision, I think, in the long term. You've got Starship, which is fully reusable two-stage rocket, or you've got Falcon Heavy, which is mostly reusable. It's launching a capsule, maybe a Crew Dragon or an Orion. It docks with the space station. The astronauts get out. They move over to the Starship. They land on the surface of the moon, come back up to this gateway, back down to the Earth. And so much is reused that it goes from this giant stack that you're throwing away to a renewable system that's taking you to and from the moon. And that's how you build a base. Each launch carries more and more material down to the surface of the moon through this ferry system, and you build up a base. And then you've got a base where they're producing propellant on the surface of the moon. And so when the lander lands, it refuels, and in fact it carries even more fuel back up to the Lunar Gateway, and then it can, as other spacecraft attach to the Lunar Gateway, they can be refueled. Like it's that infrastructure that you always imagined the future of space exploration could be. And that's what it's going to take for us to go to space and to stay in space, to go to the moon and stay on the moon, and not just go, it's too expensive, let's go home and do something else. Let's build a space truck. So yeah, both. You get the Lunar Gateway and then you build the moon base, and the two work together in tandem. And the Gateway really is a gateway to the rest of the solar system. And so you can then, your Starship, your tanker is filling up propellant. It flies up to the Gateway. You've got the Mars spacecraft arrives at the Lunar Gateway. Now it's almost out of the Earth's gravity well, and then it tanks up and then flies off to Mars. And all it had to do was carry like a little bit of fuel for the people, and that's it. So yeah, it's a pretty cool future if we get there. Didn't we solve that problem on September 13, 1999? Is that Space 1999? Pink Proportion. Who are some of the top scientists doing 3D simulations with Gaia data? So did you see the interview that I did with the person from the Gaia team? So cool. I don't know anyone who's doing like a really cool 3D map, but they've got to be. But yeah, I wonder if someone's doing like a 3D map of space with Gaia. Christopher Bergen. How likely do you think it is for Congress to allow nuclear rockets to get astronauts to Mars and deeper in space without as much cosmic radiation? The chances are pretty good at this point. Now, rockets. Now, nuclear rockets, this is an idea that's been around for decades. I just go back to like every good idea was thought of back in the 60s, and nuclear rockets were developed like back in the 60s and 70s and have been tested for decades. And they work great. You have a fission reactor, you heat up some kind of propellant like hydrogen, you blast it out the back of the rocket, you get a huge specific impulse, much better than a chemical rocket. You could cut down the travel times to and from Mars by a couple of months. They're a great idea. Now, the downside, of course, is you're launching a fission reactor as a rocket. And so the idea that's been proposed is that you fly the thing to space and then you turn it on while you're in space. And, space is already filled with radiation, so who cares? And so even though this technology has been around for decades, it's nuclear, it's scary. And so they stopped working on that and focused on traditional chemical propellants. But people are becoming more and more comfortable with the idea. And in fact, fairly recently, NASA and I think the US Department of Defense have been handing out grants for people to actually start developing nuclear rockets and nuclear reactors that can be used on the moon. And so I wouldn't be surprised if in the next decade we see an actual nuclear rocket used in space as a prototype. And the Chinese are working this as well. They've announced they're going to be sending a mission to Neptune, and they're going to be using a fission reactor as the way of getting out there. And it's like one of the few ways you can get that far that quickly and to be able to do it and give you tons and tons of electricity to spare. I mean, you're going to have hundreds of kilowatts of energy that you're going to be able to access on your mission, and you can use that for maybe it's 40 kilowatts. Anyway, a ton of energy to be able to use for your mission, for all of your science instruments and so on. There's no cost cutting required in terms of energy. You got all the energy you can handle. And actually, the Soviets launched a bunch of fission reactors into space. I think they launched like 20 plus reactors. One crashed into Canada and we're still cleaning it up. The Americans have launched one fission reactor into space. So the technology has been around for a long time, and it's just a matter of both putting in enough safety issues that people are comfortable with this working, and also working out the technical details. But this is what you do, right? You build prototypes, you test them out, and you learn your lessons, and eventually it becomes good enough for humans to fly on. So yeah, I think we're going to see nuclear rockets sooner than later. Mark Carter, best nuclear rocket invented the 60s, exploded nuclear bombs behind the rocket little ones. That is not the best. That's Project Orion, where they were dropping bombs behind their rocket. Can you imagine, like, you launch your rocket by dropping nuclear weapons behind it? I think during the time that Project Orion was proposed, they were also like thinking about ways to melt the Arctic and carve out the moon and dig giant trenches around. They were looking for any reason to use nuclear weapons. So maybe it'll work, but just think about the unintended consequences. John Stuffel. Well, why do conspiracy theorists always point at NASA when there's so many other space agencies around the world? NASA's and everything. That's a great question, and I'm going to be talking to Lee next week about science denialism. It is weird to me. Like, I think it's religious. Is the impression that I get is that the concept of the Big Bang, of space, and of a spherical Earth, etc., runs counter to things that are said in the Bible about the age of the universe, how it came about, as well as this idea of the firmament above the planet and blah, blah, blah. And so for people who take their religion very seriously, they have to run up against what science is saying that is different. And obviously, for most people, I'm sure there's a bunch of religious people in the audience right now, and you just adapt. You're like, obviously it was metaphorical, and obviously they didn't know the shape of the earth, and maybe the firmament's a different thing. Anyway, but for people who take it very fundamentally, they have to choose their belief over what nature is trying to tell them. And when we hold these beliefs in our brain at the same time, these two thoughts at the same time, they can't hold together. And so you look for anything that confirms your prior belief. You look for conspiracies. You look for pictures that, and you look for people who believe the same things that you are, so you can talk to them and agree with each other and confirm each other's beliefs. That's how you get there. And so I think space, NASA, the origin of the universe, like it is treading in the same places as religion. It's asking these fundamental questions about how old is the universe and what is our place in the cosmos and how do we get here? How did life form? Is life across the universe? And so if you have these beliefs that have been told to you and they are your worldview and they form a big chunk of your personality, it's very difficult to listen to someone who is attempting to tell you something different, and they get angry and they lash out. And like my Facebook comments are just a mess of flat earthers and conspiracy theorists and science deniers. The chat here is often a mess of that kind of a thing. So I think, like, I would love to have a productive conversation with some of the people who believe these things. And like, I just want to understand. I want to ask them questions. But I know that it wouldn't be super fun. It would go bad because, like I know I'm on a rant, but here we are. Like, think about people. Like, if there are things that you don't believe in, how often do you go out of your way to jump into their communities and lecture them, rolling your eyes, insulting people, death threats? Like, you don't. Like, it doesn't occur to you. Like if you think dogs are better, you don't just smash around in a cat fancier forum yelling at people and making an ass out of yourself. And yet that's what the conspiracy theorists and the science deniers do. And so it's like, what is driving you to get to this point? It's crazy. It's like a religious fervor, and you are spreading the good news and you are saving the non-believers from eternal torment. That is the level of motivation that people have. And it's weird to watch it unfold, to be on the receiving end of it. And I'm like, on the one hand, exhausted by it and I ignore it. And on the other hand, I'm like a little curious. Like, what's going on in your mind? I want to know. So that's how I feel. And I don't know why, but I'm going to be talking to Lee on Monday. So I think we'll get a chance to talk about it. There you go, Crypto Man. So they know they're wrong, but they're being demeaning, divisive, and disruptive. Yeah, I think they anyone heading to cat forums right now. Yeah. Yeah. So I think, yeah. Anyway, it's weird. It's weird that this is part of my life, and I try to minimize the amount of my life that it is, and yet it's ever present. It is I don't know, it's the hazard of doing this job, and it's weird to me. All right. Anyway, I'm losing my mind. So let me focus on space, because that's why you're here. Josh Russell, will NASA run out of shuttle engines for the SLS, or are they building more? Yeah, they're going to run out of engines. So the Space Launch System, the rocket engines at the bottom of the main module of the SLS, those are RS-25 engines, and those were originally developed for the space shuttle. They're a hydrogen rocket engine. They are incredibly efficient. They're the Lamborghini, the Ferrari of rocket engines. And NASA put all of this work to try and squeeze every little piece of efficiency that they could to make these rocket engines do the main job of carrying the space shuttle orbiter to space. And I've mentioned this in other times, like the space shuttle was more powerful than the Space Launch System. Space shuttle was an amazing machine. It's just that it had to carry the orbiter to space, and then the orbiter had a payload. And so you lost most of that payload capacity by just launching the orbiter to space. But with the SLS, it's really a redesigned version of the space shuttle designed to carry more payload and less orbiter. But at the bottom of the main stage, it's using those RS-25 engines. And the difference with the space shuttle and the SLS is that the core stage of the SLS will crash into the ocean and destroy those beautiful Ferrari engines each time. And I think they have 16 of them, so they've got enough for 4 launches. And then once those are done, Aerojet Rocketdyne is going to have to get cranking and build them more RS-25 engines so they can crash them into the ocean. So sad. Gordon Chin, is there some way for normal people to do SETI with detection methods other than radio? That's a really interesting question. So yes, I'm going to say yes. So the obviously the radio telescope is the way that people have been using for SETI. You listen to the signals from another star system, and hopefully you're going to have intelligent aliens sending ones and zeros, or the isotopes of hydrogen or pi or something like that. But there have been lots of other ideas proposed for SETI. So the one that's probably most likely is called optical SETI, or OSETI. And what that would be is, instead of the aliens sending a radio signal towards us, they're shooting a bright laser at us. And then hopefully they're hoping, they're going to target the laser right at planet Earth. And they're hoping that we will be watching the sky with our telescope, and we'll watch this star brighten and then dim in a very weird, artificial way. And that is the kind of thing that you could detect with a telescope. As long as you were the one looking at that star, measuring the brightness of that star over time, then you could detect that signal as it's being sent to us. That would be a way to do it. And like, the thing is that nobody is looking at all the stars all the time. Some people are looking at some of the stars some of the time. But you can take a star and you can watch it with your telescope night after night after night, and with a fairly accessible tool for detecting the brightness of the star. You could track the brightness of a star. You could detect exoplanets passing in front of the star, just like with the TESS instrument, the transit method. And you could detect some kind of weird laser signal that's being sent from that star. I'm gonna sneeze now. Okay, so a related idea is that if you are detecting the transit method, you're using your telescope, you're watching the brightness of a star, and you're watching as a planet passes in front. If the technological civilization is big enough, they've built some kind of satellite that's like a triangle or something really weird, a weird shape, a megastructure that is passing in front of the star from our perspective. And you would see this weird light curve as this triangle passes in front. And there's no shape in nature that could create that shape, that light curve. And so you would have a really good shot at detecting planets. So you can see it's very much related to get a telescope, choose a star. Oh, now I'm itchy nose. All right. So it's very much get a telescope, choose a star. And like amateur astronomers who get their own telescope and they get some, and it's not like a huge expense. Like you can spend a couple of $1,000s and then you can sign up and you can confirm exoplanets that have been candidate exoplanets that have been found by, say, TESS or other instruments. And you can actually observe those planets, or you can observe the change in brightness. So that's kind of like two ways. And I'm sure there's other ways as well, but like that's two ways that you could just imagine. Like you're out there, like there's a movie here, right? You're out there every night and you're scanning, you've chosen your star because you think that's the one that has planets orbiting around it, and you're watching and you get this weird signal. The star is changing in brightness and you're able to decode the signal, and it turns out it's an alien species that's sending us a message. So that could be you. What are we at? All right. I think we've reached the end of the main recorded show. So I'm going to stop the recording, but don't go anywhere. We will do overtime, and then we will bust through as many of these questions as we can. So, all right, I got to do my various stuff. All right, hold on. More questions in a second, but first I'd like to thank our patrons: Brian, Patrick Madden, Douglas Bell, King Petway, Fred Dunn, Sergio Sansevero, David Barnes, Jeffrey Miller, and the rest of our 1,038 patrons for their generous support. Want our videos with no ads? Join our community at patreon.com/Universe Today. And I'll also remove all the ads from the Universe Today website for life. Who likes ads? You don't like ads. $3. $3, donate on our Patreon, and then you don't have any ads for the rest of your life on our website, even if you cancel, and you're supporting the work that we do. You're helping us stay independent. We're not under the thumb of big space media. Okay, here's the ending part. All right. Well, those were all the questions that we got this week. Thank you, everyone, for asking them in the YouTube comments, as well as joining during the live show. Another reminder, we do this every Monday at 5 p.m. Pacific time, so you should come and join us. All right, we'll see you next week. Oh, and I should mention the Discord. Anton will kill me if I don't mention the Discord. Let's figure out Anton, if you're watching. Of course, you're not watching. All right, we'll figure this out. If you want a single comprehensive resource for space news, you want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so that you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. I'll put a link in the show notes. And most recently, we had an interview with Nancy Graziano, the executive producer of the Weekly Space Hangout, the cat herder-in-chief, who is here right now helping organize all of the questions and get them in front of my eyeballs. So if you want to hear how Nancy came to the system and the Universe Today Cosmoquestosphere and what her vision is, you should definitely listen to that episode. That's on the podcast. Thanks to all the moderators, and a special thanks, as always, to Chad Weber, Nancy Graziano, and Anton Poznikov. Okay, I'm going to stop the recordings. And I'm going to do something a little different this week, which is that I'm not going to look at the previous questions because I'm sure like everyone's just gone to bed. I'm going to just be like answering questions as they come in on the chat. So if you still have your question, I didn't answer it, go ahead and post it in the chat, and I will sort of make this a free-flowing consciousness with the people who are still here. How many people are here? 176 of you. So 253 of you. Okay. Tom Garcia, never give up on the mountain bike, e-bike dream. I know, I'm scared to buy my mountain e-bike because I feel I'm having FOMO. Like if I commit to a expensive mountain bike, then the new technology is going to come along and I'm going to feel sad that I'm riding on my old mountain bike. So I don't want to do that. No, Nancy, don't tag the questions anymore because I'm just going to stream of consciousness of it. PD5000, would you like to go on a date in space? No pressure. Date in space? No, I don't want to go to space. So, I dates on Earth would be fine. I have to talk to my wife. She should be into that, but James Salzman, primordial black holes or population 3 direct collapse black holes, which have more mass? Well, primordial mass black holes, those are the black holes that could be here since the beginning of the universe. And population 3, they're big. Like population 3 stars, the first stars in the universe, they could have tens of thousands of times the mass of the sun. And so, but a primordial mass black hole, they could be any mass. I mean, they're just formed in overdensities in the beginning of the universe, and they could be supermassive black holes. We don't really know. So I would go with primordial mass black holes are probably more massive than population 3 star black holes. Tesla Ranger, any comment on Blue Origin's New Shepard booster failure today? Yeah, scary, right? Like that thing's flown perfectly. It carried Captain Kirk to the edge of space as well as other people, and today one just blew up. Now the capsule ejected safely and landed, so that's good news, but it shows that space is still hard. It always is, and it will never be routine, I think, in my opinion. Sean Marson, hey Fraser, does the fusion on the sun make a noise? Yeah, it does. Like it's loud. If we had air in between us and the sun, it would be just this constant screeching in the sky from the sun. I forget the exact number, but it is loud. And it would be this ever-present just yelling from the sun. But fortunately, we have the vacuum of space in between us and the sun, so we don't have to worry about it. Andrew Pride, how much helium-3 do you think could be mined from the moon? Like we don't know how to make fusion work, and then we also don't know how to make helium-3 fusion work, and then we don't know how to mine helium-3. So probably none. Like I think like people say, oh, like helium-3, the moon is the place to go for helium-3. There's helium-3 here on Earth in the oceans, not as dense as it is up on the moon, but it's also down here on Earth, and it's easier to get at. So I think we will. Cryptoman 5000, do you know when Webb will image Proxima? Have you submitted any projects for Webb? I haven't submitted any projects. I don't know when they're going to image Proxima, but it's definitely going to be on the list. Vista Tootie, how is your reforestation of Canada going? It's going well. I've built a nursery of trees, and I've been taking a ton of cuttings and replanting the trees, and I've made my own batch of potting soil out of my local tough. I forget what you call it, but like the forest material. I've made a really cool potting mix that I'm planting all these trees into. I've got tons and tons of various native shrubs and trees that I'm growing. But it's not enough. I need to I need to grow thousands of trees. We get forest fires here on Vancouver Island, and this whole forest around me is just Douglas firs, and they're all like little bombs. When you have these big forest fires, these Douglas firs just go up in flames. And so I want to cut a bunch of them down and replace them with deciduous trees, cottonwoods, alders, maple trees, things like that. And so I need to grow thousands of these trees. It's sort of, it's terrifying. And then my chainsaw broke. So my chainsaw's in the shop right now. So I really want to cut trees down, but I can't right now. So, John Suffel, did I hear that right? Generation 3 stars could be tens of thousands of times bigger than the sun. Yeah, and the idea is that these pop 3 stars, the first stars, I don't know, it's a terrible name, but the first stars could be tens of thousands of times more massive than the sun, and they would have collapsed directly into black holes, no intermediate stage. Nancy, are you planting Fraser firs? I didn't know. Is that a thing? A Fraser fir? I've never heard of that. Robert Allen, how can the DART mission predict the outcome of an impact if they don't know the makeup of the asteroid? Can the asteroid be loose enough to absorb the impact? That's why you smash into it. Like, you don't know. You think you know what the density. I mean, the cool thing about having an asteroid and its moon is that between that you can work out the mass of the asteroid and the moon, thanks to Newton's laws of gravity. And once you know the mass of the moon, and you know the size of the moon, you can work out its density, and that tells you what it's probably made out of. And so they make a prediction that if you crash this much spacecraft into that much rock, you should have this outcome. But the devil's in the details, and that's why they're actually doing it, is to smash it into the moon. Cryptoman 5000, chaps saved my leg. True story. Chaps saved my leg too. I wear chaps when I use a chainsaw, and it wouldn't have been like a cutting my leg off moment, but I definitely was like not quite done. I was a little sloppy, and the chainsaw scraped up against my leg and caught on the chaps and came to a halt. And it would have been a nasty gash on my leg that was nothing, no problem. So yeah, if you ever use a chainsaw, definitely buy the chaps, and like don't even like an electric chainsaw. You're like, I just want to make this one cut. Every time I do, I'm like, okay, put on the chaps, put on the helmet, put on the ear protection, grab my gloves. Don't get stupid. Jay, what is the theoretical mass limit in which a terrestrial world becomes a gas giant? Would the process, and would it affect life there? Well, you don't get a gas giant from a terrestrial world. Like, they're two different kinds of planets. But the thinking is that if you have like a Neptune-sized planet that's close to the star, then the star will blow away all of the material, and you're left with a super Earth. And that may be how you get super Earths, is they are the cores of Neptunes. But a gas giant is has a very different structure. It's mostly hydrogen, helium. It's farther away from the star, etc. Bravo 01, is the gas in a nebula flammable, and what would happen if you ignite it? Yes, it's flammable. It's hydrogen and helium, but hydrogen is flammable, but you need oxygen to light it. And so unless you're willing to bring a nebula's worth of oxygen to your nebula, you wouldn't be able to ignite it. It's the same problem with going to Titan. Like, Titan has lakes made of rocket fuel, and yet they won't burn because they don't have any oxygen. But if you were able to bring your oxygen, then you could just dip up the rocket fuel on Titan and use that to fly your spacecraft. Chainsaws love meat. Let's see. Ben Samry, could gravitational waves theoretically be techno-signatures of advanced alien civilization using a warp drive? I mean, aliens can do anything, right? So who knows? Question mark, question mark, question mark. Alien magic goes here. But the amount of energy that is required to generate a gravitational wave that is propagated past the Earth takes the most extreme events in the universe. It takes colliding black holes. So if a alien has a spaceship that is made from colliding black holes, then sure. But I doubt it. We know that there are black holes. We know that they collide. That seems to be the most likely evidence. But there are gravitational waves everywhere, all the time. You are generating gravitational waves as you walk around. The Earth is generating gravitational waves as it goes around the sun. Move your hands. You're generating gravitational waves. It's happening right now. So if an alien had a spacecraft that had like a black hole drive or something, and they'd turn on their warp drive, and maybe it would generate gravitational wave ripples. And once we have more sensitive gravitational wave detectors, maybe we'll find it. Yeah, Dr. Ed Elcott, cryptologist. Those Husqvarna hard hats with a screen and built-in earmuffs. That's exactly what I have. Yeah, I have the one with the built-in screen and the ear protection and the helmet. T260. How much is the different tiers of your Patreon group? Well, the lowest tier is $3. $3, and you can sign up for Patreon and then just cancel immediately. And then I will send you login information for the Universe Today website, and then you'll see it ad-free for the rest of your life. Rob Music. Aliens Can Do Anything should be on a t-shirt. Yeah, that's a good one. I love it. Plastic Pinocchio, do you think that FTL is achievable given the known laws of physics? No, it is not achievable using the known laws of physics. We need new laws of physics, but the ones that we know do not let us go faster than the speed of light. Tom, I do not know the reference. Adol Chapman, will James Webb check out Tabistar? Probably. I haven't heard that they've done it. Did you see today someone you pointed it at the Orion Nebula? So we got the first image of the Orion Nebula from James Webb. Wow, so cool. Pim Jim, there's a gravity spectrum. There may be more spectrums. Yeah, it's a really interesting idea that, that there is we think of the electromagnetic spectrum with radio waves on the one side and visible light and then X-rays and gamma rays on the other side. But there is a spectrum of gravity. There is really long, low frequency gravity waves from supermassive black holes merging together. And then there's really high frequency ones from neutron stars colliding, or maybe even somewhere in between, there's the background hum of the universe. And imagine if you could see the whole universe in gravity waves. It would be about mass moving as opposed to the radiation that they give off. It would be really weird. And we're so at the beginning of this. Like, the impossible has been made possible. And now as new telescopes come online, we're going to be able to see more out there. Okay, it's a novella in the Expanse universe. I haven't read the Expanse books. I watched the TV show. Sorry. Jay, what would it take to slow a photon all the way down? Well, you can't. Photons go the speed of light. You can't slow them down, but you can move a photon through a medium. So I think you can move photons through something like rubidium gas, and they go slower than walking speed. You can outpace a photon in that, but I don't know exactly how it works. Yeah, there you go, rubidium. Old gamer noob, is there anything out near James Webb in the Lagrange point that might get in its way? No, the Lagrange point that James Webb is at, a Lagrange question, the first of the night, is unstable. So anything there will just drift away. And so it's got to have a rocket engine on it. And the only thing out there is like Gaia is out there with it. Maybe another couple of spacecraft. So that's it. So no, nothing's in the way. T260, I've heard them talk about this, but are there any plans in the works to service Hubble now that we have Dragon? No plans. Hubble is doomed for re-entry. Pray for a country. Perilous situation on the ISS and the space toilet breaks down. What do? They have diapers. They have bags for this. Like this, that is not a flee to the airlock problem. The astronauts are comfortable with this. Dr. Ed Elcott, cryptologist. To the best of your knowledge, what is the largest number of stars that orbit each other within a single system? 5 or 6? I think that the record right now is 7. But theoretically, it could be higher than that. Plastic Pinocchio, will LUVOIR be able to directly image exoplanets, particularly terrestrial ones? Yes, it will. It'll directly image exoplanets. But I mean, the upcoming extremely large telescope is going to be able to do that. So directly imaging exoplanets is coming. You need this, it's the coronagraph, the sunshade. You need to block the light from the star. But yeah, that's one of the jobs that LUVOIR will do. Although LUVOIR isn't going to happen. So, there you are. It'll chap into Planet 9. Any progress? What methods? No progress. What methods? Wait for the Vera Rubin Observatory to come online. It will find Planet 9. Dustin King, I wonder if solar panels and a solar sail would be enough to keep a spacecraft at L2. Probably. I think so. Yeah, I think a solar sail would keep you there. Arjun, has NASA run tests to do better laundry in space? I hear things get a little ripe out there. We just did an article on Universe Today about that. I think it's like the space, the socks, the final frontier. It's on Universe Today. Our new writer, Seth Lockman, just wrote an article about this. So check that out. It's right on the site. Shadow Mask, are there Lagrange points between stars? Do you think the interstellar wind would disturb the orbits? No, there wouldn't be Lagrange points between stars. You get a Lagrange point when you have a massive object like the sun, and a less massive object like Earth, and then you get the 5 Lagrange points. But you need those things. You need to have the massive object, like the supermassive black hole, and then you need the small object, like the star. Then you're going to get Lagrange points. But you always need that very massive thing, less massive thing, that gets you Lagrange points. Zach Diecast Master, what happens when you have diarrhea in space? It's exactly like when you have diarrhea on Earth, except it goes free floating. What a nightmare. You lose friends. Yeah. Samuel Garland, do you have any takes on space ethics? You're going to have to give me a specific question. I have lots of takes on lots of different ethical questions. Same on Sneeze. Do you know if James Webb will see exomoons that are potentially habitable? Yeah, James Webb theoretically could be an instrument that could detect exomoons. Here's hoping. Old Gamer News, approximate theoretical mass of Planet 9, like Neptune. Okay. I think we've reached the end of the episode, so I'm going to go and eat some dinner. Dr. Ed Helcott, could you propel yourself? It is explosive. Yes. If you had explosive diarrhea in space, you would go in the opposite direction. Nasty. All right. Thanks, everyone. Thank you for watching, hanging out. It's great to be back. I'm having so much fun doing these shows again, and it'll be nice when they actually make it out live onto the internet as opposed to. But you get the sneak preview. So thank you, everyone, for watching. Thank you for everyone who asked all the questions. That was a lot of fun. Thank you to Nancy for gathering up all the questions and putting them in front of me so that I can actually see them. That is awesome. And thanks to the other moderators for hanging out. Like I said, Dr. Brian Keating later on this week. Many interviews next week. We got our weekly Space Hangout coming. We had to delay Astronomy Cast. That's coming on Wednesday. We've got Space Bites coming on Friday. All the space news you can handle. All right. We will see you all next week. Thanks, everyone.